for the introduction. Great. So, good morning, and thank you for having me here. So, the topic for today is the need for standardization of Ethernet firewalls in the automotive world. So, if you will come from IT world, it's quite straightforward, right? You need a firewall, and everyone knows what to do. But when it comes to the automotive world, the requirements are a little bit different. Also, you have different challenges. So first, I will first start with, let's say, introduction on why firewalls are needed. What are the challenges that we typically face when working with firewalls with different OEMs? How standardization can really help to solve this problem? And yesterday we talked about a lot about the Yang model, but how an AutoSAR approach can also help in that direction. So, looking into firewall and automotive. So, first we can start with the trends in EE architecture, and we more or less divide the trend into three areas. One is the old EE architecture, where everything was connected with each other, all the ECUs, with a CAN bus. So, we say it's unfit for future mobility. Then came domain-based EE architecture, where the restructuring of the network was more on logical base. So here we found more improved security and bandwidth, and there were limited cross-domain communication. Then the future, what everyone talks about is the zonal EE architecture. So here, the restructuring of the network is not logical, but it's more on physical. So like you can have front left, front right, rear left, rear right. And here it helps you with reducing the wiring harness, but it requires a high bandwidth communication link. Also, the idea here is that we reuse a lot of hardware and software. But when it comes to reaching towards zonal EE architecture, the steps are different for different OEMs. So everyone has a different base which they are using to go towards zonal. So today we see there are different steps for different customers. And hybrid solution is the very first logical solution for them if they don't skip generations. And that's why, like even when it comes to the firewalling needs, it's a little bit different. Why simply you need a firewall? So how this is, the need is driven. So number one, there are a lot of legislation requirements like GBT in China that clearly defines what should be filtered, at what level you should inspect messages and what you do there. With UNECE, it talks about monitoring vehicle when the vehicle is already on streets, how you can react on it. And there are many more legislations which are driving this requirement. Then, if you want to have a state-of-art solution, you can add firewall as a security checkpoint at the entry points for the messages. And then, from the IT world, we know it very well. If you're using Ethernet, you put a firewall also in your home, right? So we can simply apply the same approach on the automotive side. So what are the key changes when you move from domain towards zonal EE architecture? So what we see here is that the distribution of domain-specific sensors and actuators, connectivity over the car, move towards the zonal edge nodes. So the domain functionality is sometimes handled in the central compute, but also it's sometimes happening on the edges. And then we see a lot of use cases where from the edges, the messages are encapsulated in the Ethernet message, transported over the backbone, and then again, it is opened up for doing more stuff. And so the key summary here is that the communication policy is now complex and distributed. It's not like before, let's say an EE architecture where you had a central gateway and multiple domains, messages were coming in from a domain and then it was going to some other domain and translated by the gateway. But in the zonal EE architecture, it's mixed up. So a same ECU can be responsible for multiple different functionalities. So, there are different safety requirements, security requirements, and the requirements are now distributed all over to the EE architecture, and there is no central point where you can put everything and you're fine with it. So let's say coming to the zonal e-architecture, I mean, this is one of, I don't know, many different possibilities of a zonal e-architecture, just one example. So if we talk about the use cases here, I mean, we can see that there are firewall and IDS use cases on the central vehicle computer at the compute unit. If you go down towards Ethernet switches, you can have requirements on firewall and IDS there as well. I mean, the switches here are not as powerful as, let's say, a data center switches, which are power hungry and they have a lot of capability, but still you can do a lot more there. Then there are also requirements for firewall and IDS on domain controllers, but also the end ECUs can also serve specific use cases of firewall. So let's say, for example, if you talk about EV charging ECU, like it's a pretty small ECU doing Ethernet communication for transactions, like the communication for charging happens over Ethernet, and there you have a use case of firewall. So we see that the use case is, first of all, at multiple different levels, and yes, one-stop solution is not going to work here. So the key challenges that we see in automotive firewall is, number one, there is no standardized way to configure a firewall. So we see there is a high synchronization effort between OEMs and tier ones on what to do and how to do. That's my experience here. And the configuration process is also very prone to errors. I mean, we talk about intrusion detection and prevention solutions, so which is about monitoring your vehicle when it's already on street. Firewall is also blocking messages, detecting some security incidents. Why don't we use it as a sensor and connect it to IDS? So that's another use case and a challenge, I would say. And then there is no minimum agreed set of firewall functionalities. So if you look into different customer requirements, I mean, some are talking about really detailed level of inspection, and some are super basic. So there should be at least a minimum standard on what should be done. So, and we think AutoSAR can be used as a platform to solve those challenges. And the question is, why AutoSAR? So, I mean, we all know what AutoSAR is, so I will skip that. But why we can use AutoSAR to do this work? So number one, I mean, it's widely used in the automotive industry. Everyone is, more or less everyone is using it. Second, I mean, we can use the existing AutoSAR tool chains to do the configuration for firewall. And I mean, it's an industry consortium. So more or less, if you work on it, you are aligned on the strategy for most of the OEMs here. So for when we worked on the standardization, what were the key use cases there? So I mean, we worked on, let's say, filtering of incoming and outgoing communication messages. And here we worked on stateless packet inspection, stateful packet inspection, and deep packet inspection. We worked on standardization of, let's say, some common language to define firewall rules. Also, we introduced how you can get in the state of vehicle linked towards a firewall rule. And we also worked on standardizing AutoSAR security events. So like a firewall, if it's dropping messages, it can generate some security events which are compliant to IDS manager, which is already standardized in AutoSAR. And the applicable AutoSAR standards here are both adaptive AutoSAR and classic. So when it comes to adaptive, we already worked on the standardization, and it was released last year in R2211. When it comes to classic, it's being worked on this year, and the plan is that it will be released by end of this year. So yes, as I mentioned, for adaptive, it's already released, and it's part of R2211 release. So there is a functional cluster introduced. It's called ARA-FW. And here we, let's say, you can see on the picture on the right side, and here we define the complete firewall functionality. And here we address the architecture of firewall, the language, vehicle state-based inspection, as well as the connection to IDPS ecosystem. So ARA Firewall is basically a management module in Adaptive AutoSAR, and it takes the firewall configuration in Adaptive AutoSAR, let's say AutoSAR format with help of RXML files, and then it helps you to configure the underlying firewall engine with the firewall rules. So the firewall is typically integrated at the OS level, so it could be on Linux based on IP tables. How you integrate it, it's done in a similar way. With QNX, you can utilize the packet filter interface to integrate your firewall on QNX side. And if for any other module, like proprietary firewall engines are also feasible. And then we also define some interfaces. One interface is how to provide the state of vehicle to the firewall to make it state aware. And then the other interface is to, let's say, take the security events from the firewall and pass it on to the IDS manager. So we talked about multiple challenges, and let's see how the AutoSAR is solving it. So when we talked about there is no common language to talk about firewall configuration, with AutoSAR, we introduced the common language for configuring firewalls. Then the second challenge I talked about was that there's a high effort on communication between OEM requirements regarding firewall. So, with ARXML, we defined a common exchange format, which is making it easy and less tedious. And we can use the AutoSAR tooling support to configure the allow list or whitelist to generate like the communication matrix. So you don't need to reinvent the wheel, work on it, and extract the messages. And really, for a proprietary solution, you need to do a lot of work. You can use AutoSAR for that. And the firewall configuration language defined in AutoSAR manifests specification as UML. So we can look into more details here. So what we have done here is, if you go from left to right, it's really kind of representing the OSI layers. So, we define what can be configured at the data link layer side, what can be done on the network layer side, be it on IP4, IPv6, ICMP. Same on the TCP and UDP pattern. So, we can go with stateful packet inspection as per RFC 793 and do a lot more. Then we also defined how you can do application layer filtering, be it on some IP, diagnostic or IP, DDS, or some others, deep packet inspection protocols, but also we have left scope for some protocols which are still proprietary. And so here we define a generic deep packet inspection module where you can define patterns on what should be filtered at application layer and can be done. On top of that, we added rate limiting. So the idea here is that, also from a compliance perspective for some regulations, you need to make sure that you are able to detect if someone is, let's say, sending messages at a higher rate than it's required, then you should be able to detect it and in certain cases react on it. So that is also something the firewall is able to take care of in the standardization part. And then the final thing is the action. So, if everything is successful, what to do with it? Do you want to block it? Do you want to allow it? Do you want to raise a security event? So you are allowed to more or less connect an action to that. So, again, coming to the vehicle state dependent filtering. So, the challenge here is that the network traffic highly depends on the vehicle state. So it could be diagnostic mode, parking mode, vehicle running mode. And there are specific network messages which are only allowed in certain states. For example, there is a message which comes to flash an ECU, and you definitely don't want it when your vehicle is driving. So you are able to associate these kind of, let's say, vehicle states towards a firewall rule. And that is also can be easily covered by the standardization. So now the question is, we talked about a lot about adaptive AutoSAR. We will have a kind of similar approach on classic AutoSAR, but what is left here is the switches. So we don't want to clearly specify what to do with the switches and how to do with the switch, but as part of the classic AutoSAR standardization, We also consider switch as a module, and we, in the, let's say, so the scope we define in the standardization is also covering the switches, but it is making sure that it is keeping the proprietary switch-based functionalities away from it. So it can be a, let's say, vendor-specific module. One example is TCAM. So, I mean, every switch vendor, someone calls it TCAM, someone calls it compact field processor, and the configuration of it is different. So we consider those parts in the standardization, but we still keep the implementation out of it. So then the final part is connection to IDPS. So, I mean, I already talked about, I mean, IDS Manager is standardized in AUTOSAR. So we can utilize the firewall as it is for, let's say, to raise security events. And just like other IDS sensors, I mean, now the firewall can also be part of it. Like CAN, Ethernet, host-based IDS, and different IDS sensors, now firewall can generate security events. It can be collected and then send it to the vehicle backend on the VSOC. So, with respect to the security events, we have standardized 15 different firewall security events for IDSM. So, and it is covering all the scope that I talked about before, like at multiple layers of OSI. And more or less with help of this, I mean, if you receive an event on the backend side, you will be able to somehow backtrace and know what went wrong in your vehicle. So, what else is to come? So, we address the current specification with adaptive. Basically, configuration via standard language is possible now on adaptive side. We will bring the same to classic this year, and we will also bring the similar thing to switches this year. And we expect that in R2311, it will be standardized. I mean, it's still not there, but that's the expectation. Yep, I would say that's all from my side. Thank you.
So thank you very much. Are there some questions? Yes, please.
Thank you for the presentation. A question, who watches the watchers? So when you are configuring the firewalls in the switches and ECUs, you didn't talk about authentication at all.
So let's say, I mean, yeah, I kept it away from the standardization part of it, but I mean, let's say you talk about switches. What you are putting in there, I mean, it is, I mean, you expect the hardware to have some of the basic security features like secure boot. In the modern ones, you also have HSM, where you can store the key and you can do more security specific things. But these are part of the infrastructure that you utilize to have the rule sets there. So, but yes, I mean, this is something we don't cover in the standardization for sure.
Okay, thanks.
So I do have a question. Does the standardization also help to improve the switch hardware, or is there a possibility to embed stuff in or offload stuff in hardware acceleration?
Yes, definitely. So this is, let's say, when we cover the switches, this is an area that we try to touch. So I mean, there are multiple stakeholders there. Everyone was not part of AUTOSAR consortium, but we still tried to talk to all the switch vendors to make sure that it is not really hitting them immediately, but if they are aligned with the idea. But they really, I mean, that's the idea. I mean, we are talking about Ethernet communication, and if we will limit the bandwidth by just processing everything in the CPU, it makes no sense. So the idea is that you still utilize some software, but wherever hardware acceleration is available, you utilize that and to make it work in a faster way. And that is something we have considered for Classic.
Sounds good. Steve.
Yeah, so very interesting presentation, thank you. So I noticed you were talking about setting up stateful rules where certain traffic isn't allowed depending on what state you're in.
Yeah.
Have you looked at the Airbus problem?
Which problem, maybe?
The A320 was the first fly-by-wire airplane.
Yeah.
All software defined. They were doing an air show, the chief pilot was flying a regular landing, and the intention was when he got close to the ground, he'd firewall the throttles, pull up in a steep climb. He pushed the throttles up, which are nothing more than position encoders to the flight control. Nothing happened because the airplane said that's not an allowed maneuver when you're landing. If he'd pushed the go-round button, it would have given him go-round power. So I'm just saying, when you're doing this, make sure that you're not eliminating the ability to do something that might need to be done. That's all.
Yeah, so basically from a standardization point of view, we are not blocking anything. So
Okay.
still, let's say, be it the OEM or the tier one, someone is going to own the rules that's going in.
Okay.
So whatever you do, someone needs to do the configuration. As part of the standardization activity, we are making this easy. So,
All right.
so just reducing the chaos.
Okay, thank you.
Yeah, thank you.
All right, next question.
Good morning. I'm John Simon from Intrepid. When I think of firewalls, I think mainly in the context of security and preventing fault states. And you mentioned QCI, which is part of the TSN tool set. So I think of other traffic shaping more for bounding latency. So is there overlap between firewalls and other traffic shaping, or are they actually all the same thing and should be managed as such?
So I would say, TSN has to be considered as part of, let's say, when you are doing things on the firewall side, the TSN part needs to be considered. There are certain things that we took care of in this version of the standardization, but the idea for next year is that we will invest more time in TSN because, you mentioned QCI, which also talks about per stream filtering and a couple of other things. We can take over some things from there when defining the rules.
Okay, yeah, it would seem they share similar resources
Yes,
for
exactly.
deep packet inspection,
Yeah.
stream identification. Things like that.
So I really see them coming together.
Okay, thanks.
Yeah.
Thank you. So thank you very much for your presentation and your answers.
Thank you.
Thank you.